Okay, forgive the sloppy writing, but my Apple Pencil is dead. For chapter 18, 45b. Okay, you've calculated the delta G standard in part A, right? And you got 35.4 kilojoules per mole. And for part B, it wants to know the delta G. So for part B, you have to use this formula. Okay, so you can use the 35.4 kilojoules per mole for your delta G. If that's in kilojoules per mole, then of course you got to be sure your R is also the R, that's for kilojoules. The temperature you're just going to use, be sure it's in Kelvin. And remember to calculate Q, you take, it's like an equilibrium constant. So for Q, you're going to take products over reactants, raise the power of the coefficient, and that's where you use the numbers it gives you in B. So you take the PCl3, which is 0.27, times the chlorine, which is 0.4, and you divide that by the PCl5, which is 0.0029, okay? And then that's the math to do part B. Now, on chapter 18, number 55, it says to predict the signs of the delta H, the delta S, and the delta G when ammonia melts under different conditions. So the first one, you've got ammonia melting at negative 60 degrees Celsius. On the second one, it's melting at negative 77.7 degrees Celsius. And on the third one, it's melting at degrees Celsius. Okay. And you're told that this is the normal melting point, is negative 77. Okay, well, melting is, in order for anything to melt, it's going to have to absorb heat to melt. Ice to melt has to absorb heat. So that means it's endothermic if it's absorbing heat. Every one of them's melting. So for every one of them, the delta H is positive. Okay, this is 18.55. It's because I'm using a little rubber pencil instead. Okay, now melting also helps us with the delta S, because when something is melting, it is going from a solid to a liquid. That means it's getting more disordered. Okay, so am I looking at the right line? If it's getting more disordered, that means the entropy is increasing. Okay, and then finally the delta G, think of that, because you know that's the free energy of will it happen or not. But think of delta G as will it happen. Okay, so at the equilibrium point, negative 77, delta G is going to be 0. Now, negative 60, that's warmer than negative 77. So that's going to happen. Delta G is going to be negative. Negative 100 is colder. It's not going to melt when it gets colder. So that's going to be not spontaneous. And that's 55. Okay. And then, okay, on 19.1, the difference on that one is really, in the lectures I did it, I only did it in acidic solution, which means all you added every time was hydrogen. But C part is in a basic solution. So in a basic solution, you're going to have to add hydroxides to it. Okay, and then you're also going to have to add hydrogens to balance those hydroxides. So that one's a little different. And if I were you, I would just focus on the acidic ones. Number 11. Okay, on number 11, you have to be able to identify the cathode and the anode, because reduction is going to happen at the cathode and oxidation is going to happen at the anode. And so you can then, once you know which one's going to be reduced, let's see, you got silver and aluminum. So the silver one's going to be the reduction one. Okay, that means you're going to write that reaction exactly like it is on your standard reduction potentials table. And the aluminum is going to be the oxidizing one. So you're going to have to write the reverse of what it is on the standard reduction table. So hopefully that video helps explain better than if I typed them.